In Exploration 10.3 and Section 10.3 in general, we learn about linear regression, and that is where we try to find a straight line that will fit as well as possible to the points in the scatter plot. So some of this will bring you back to your days in algebra class, and I hope that will be a good thing and that some of this will hopefully be somewhat familiar to you. Alright, so the question here in Exploration 10.3 is whether we can predict height from footprints. If a footprint is taken at the scene of a crime, can it help to predict the height of the criminal? In other words, is there an association between height and foot length? So a sample of 20 statistics students measured their height in inches and their foot length in centimeters. So the observational units, hopefully you've got this down pat. That would be the 20 statistics students. And the two variables recorded are height in inches and foot length in centimeters. And the question is, which are we going to let be the explanatory and which is the response? Now, if you think in terms of depend, which of these might depend on the other? First of all, I think it could go either way. You might feel like how long somebody's foot is probably depends on how tall they are, and that makes sense. But because of the research question that we're using somebody's footprint to predict their height, then that is going to mean that for our purposes here, the explanatory variable is going to be foot length in centimeters, and the response is going to be height. So in other words, and that's in inches. In other words, we think that taking somebody's footprint and measuring the length of their foot at the scene of the crime might help explain how tall they are. So both of these are quantitative, as will be the case, quantitative, in Chapter 10. Okay, and then Part C asks, is this an observational study or a randomized experiment? This is an observational study. Of course, we can't randomly assign, as we would in an experiment, the students or the whatever the observational units are to the explanatory variables. So we can't randomly assign students to foot length. That doesn't make any sense at all. We can just measure, record, and observe. Okay, so you're going to get the data that is in, once again, the Miss D's video lectures Chapter 10 folder, Exploration 10.3 data, and paste that into the correlation and regression applet. And we're going to go back to what we learned in Section 10.1. We're going to comment on direction, strength, form of association, as well as unusual observations. So even though I have the data, this screenshot of the scatter plot here, I hope that you will pause the video and get the data and paste it into the applet yourself. There's going to be some interactive things for you to do in the applet shortly. Okay, but I went to the applet and here's the screenshot. And so again, notice the foot length that we've decided is explanatory is on the horizontal axis, and height, the response, is on the vertical axis. Now, I did ask the computer for the correlation coefficient, and you can see that it came out to be 0.711. And that's pretty high, right? That's into the strong in terms of the strength of the association. Clearly, these points are not only increasing from left to right, so we have a positive direction, but also they're pretty close together in terms of forming a line. I mean, certainly they don't form a definite exact straight line, but they're not too scattered, and so that's what makes the strength strong. So clearly the form is linear, right? So there is, I'm going to do form first. Well, I'll do strength first. There's a strong, and then I'll do direction, positive, and then form, linear association, And I want to state this is between height and foot length. And if we could still be on campus, I would have had you all do an activity where you did measure your own height and your foot length, and we would have our own class data, but unfortunately we can't do that. And in this case, no unusual values. Right? There are no points that don't fit the overall pattern or are far away from the rest. Again, if we kind of put a big band around these, they all sort of fit the increasing trend, and none of them kind of look strange and way outside the pattern of the rest. Now, number 3 says, would you say that a straight line could summarize the relationship between height and foot length reasonably well? Sure. Again, these points don't fall exactly in a straight line, but they're not super scattered. So we can imagine a straight line doing a decent job of summarizing the points. Okay, so we're going to go into the applet, and we're going to do as this says. Check the Show Movable Line box, and then we're going to kind of move the line around, and we're going to move it until we think we have our best line in terms of fitting the points as well as possible. Okay, so we're going to go to the applet, and again, please do this for yourself as well. It's important that you get this experience. We're going to check the Show Movable Line box. And what it gives us first is a horizontal line, and this is a little bit challenging for me on my tablet. If you're on a regular laptop or desktop, it would probably be pretty easy. But you want to try to point and click and drag on one of those green boxes. Like I said, it's kind of challenging for me on my tablet. And move that line around. And I'm doing my best, but you can be doing a better job, and if I could do this on my laptop, it would be much simpler. If you click and drag on the middle box, you can kind of move the line up and down. There we go. I did a reasonable job. And I would like it if I could move this line up a little bit. That's pretty good. I'm going to say that's good enough for me. And what you notice on the screen is we have underneath Show Movable Line, and when you are clicking and dragging on yours, you can watch that equation change. It looks like height with a little caret equals 29.7 plus 1.3 times foot length. Okay, so back to the applet. Move the line until you believe your line best summarizes the relationship. Write down the resulting equation for your line. So the caret doesn't come out very well on the internet, but it should be height with a hat on it. And I got to go back and look at mine because I already forgot. 29.7 plus 1.3. 29.7 plus 1.30 times foot length. Okay, and it questions why you believe your line is best. I'm going to say comes pretty close to all the points. Okay, so now we're going to use the applet again in an interactive way to try to think about what does best mean. Now, in part C, I'm sure the answer to this is no. Everybody's not going to come up with the same equation. So part D says, how can we decide whether your line provides a better fit than somebody else's? Suggest a criterion for deciding which line is best. So I'm going to say the line that is closest to all the points. So what they say here is we can minimize the distance of the points to the line. These are called residuals. So if a point is above the line, it's going to have a positive residual. And if a point is below the line, it's going to have a negative residual. Okay, and so the residual, as it says here, is observed minus predicted. So in other words, if we have a point above the line that is observed and we subtract where the line is below it, that gives us a positive result, and negative if the point would be below.